Welcome to the Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we're going to be answering the same question that we had in the last video segment. We're just going to have a little more complex of an example to look at. So the question is, how do you multiply rational expressions? And notice I've put a 2 here to show it's the second video in this series. So steps are the same. First, you want to factor all the numerators and the denominators. Then you'll write it as a single fraction with the factors being multiplied. Thirdly, you divide out any common factors between the numerator and the denominator. And then finally, you're either going to write it in factored or polynomial form. Let's take a look at the example. Okay, so we have a little bit more complex of an example here, which is 5x plus 5 divided by 7x minus 7x squared times 2x squared plus x minus 3 divided by 4x squared minus 9. So, oh, crap. Yeah, I wrote it down wrong. Sorry. All right. So let's go ahead and take a look at this example of rational expressions being multiplied. We have 5x plus 5 divided by negative 7x squared plus 7x times 2x squared plus x minus 3 divided by 4x squared minus 9. So the first step in our process is to factor all numerators and denominators. So you can see I've left a little section off to the side to go ahead and do that so that you can see my factoring. So we'll first start by factoring the first numerator, 5x plus 5. And this has a GCF of 5, and when we divide that out of both terms, we're left with x plus 1. So we have our first numerator factored. Now we'll move to the first denominator, and that is negative 7x squared plus 7x. And you should remember from when we talked specifically about factoring that you never want to have a leading negative term with your polynomial. So we will factor out, instead of just factoring out a 7x, we'll factor out a negative 7x so that we're left over with an x and a negative 1. So that factored out is negative 7x times x minus 1. Moving on to the second rational expression that we're multiplying with, we have 2x squared plus x minus 3. Okay, so I'm going to use the AC method of factoring with this particular trinomial. So I multiply a times c and get negative 6. Now I'm looking for the factors of negative 6 that add to make positive 1, which is b. That positive 1 comes from the understood coefficient on the bx term. And in thinking about the factors that multiply together to make negative 6 but add to make positive 1, I come up with positive 3 and negative 2. Now we rewrite the polynomial, busting up that bx term so that we can finish this process through factor by grouping. All right, so I'm just going to group those first two terms together because they have a common factor of x. And I'm going to group these last two terms, and they will have a common factor of negative 1. So now I'm just going to factor those GCFs out. So we have x times 2x plus 3, and factor out a negative 1 here, and we're also left with 2x plus 3. So that trinomial factors as 2x plus 3 times x minus 1. And last but not least, we have a difference of squares, 4x squared minus 9, which factors as 2x plus 3, 2x minus 3. All right, so we have all of our polynomials factored. So we are ready to take those factored forms and transfer them back to our original problem. So our problem written in factored form actually looks like 5 times x plus 1 divided by negative 7x times x minus 1. And we're going to multiply that with 2x plus 3 times x minus 1 divided by 2x plus 3 times 2x minus 3. That difference of squares there. Okay, so believe it or not, all we've done is finish the first step, and that's actually the most labor-intensive part of this process, is just getting everything factored out and getting your rational expressions ready to multiply. So the second step is to multiply your rational expressions into one single expression. So we have 5 times x plus 1. You multiply fractions straight across, so we'll just go ahead and multiply that 2x plus 3 and then the x minus 1 on the end here. And that will be divided by negative 7 times x minus 1 times 2x plus 3 times 2x minus 3. All right, so second step complete. Now we're ready to move on to the third step, which is to divide out any common factors from the numerator and the denominator, because we know that anything divided by itself is 1. So we come back and look, and we have a common factor of 2x plus 3. 2x plus 3 divided by 2x plus 3 is just 1, and we're multiplying with a 1 so it doesn't show up. X minus 1 divided by x minus 1 is just 1. And I just kind of glance at the rest of it and see if there are any other common factors. I don't see any. So I'm ready to rewrite this. I have 5 times x plus 1 divided by negative 7x times 2x minus 3. And the only thing that we have left to deal with is it's bad form to have a negative leading in your denominator. So if we think about this in very general terms, we have a positive being divided by a negative. And what that means is this entire expression is going to be negative. So to get that negative out of the denominator, we just call the entire expression negative and transfer the negative out front. So we have negative 5 times x plus 1 divided by 7x times 2x minus 3. Now this is a completely acceptable form to leave your answer in, nice and factored. However, sometimes you may want to write it as in the expanded polynomial form, and that would just mean going back and distributing the 5 to both the x and the 1 in the numerator, and distributing the 7x to the 2x and the negative 3 in the denominator. So I'll just also write that answer. Either or is completely acceptable though. So the whole thing is negative, and we have 5x plus 5 when I distribute the 5. And in the denominator, we have 14x squared minus 21x. So you'll just want to check with your instructor to see which answer, and just know that if you're using your textbook to work problems, they may give the answer in either form. So you have to know how to go between the forms. And that is our example. or more complex example of multiplying rational expressions. I hope that this has been helpful for you. If you have any other questions about the process of factoring, then writing it as a single fraction being multiplied, dividing out common factors, or how to write your final answer, please make sure to contact your Highlands instructor. Thank you so much.